So we've just been working on section 4.4. We'll continue it here in this video. And the beginning part here where we left off is sort of a summary. It includes some things that we've just been talking about as a result of our rational zeros theorem. And it also kind of brings back a few things that we've talked about in the past and puts them all in one place for us. So we've just been talking about the fact that if R is a rational zero of f, then we know that x minus R is a factor of f. A little while ago, we also talked about the multiplicity of zeros. Remember how back at I think it was the very beginning of this section, we had a factor of x squared, and it turned out to be a zero of multiplicity 2? In general, if we have a multiplicity of m, that just means that this factor occurred m times, so that we got x equals r, m times. So if we have a zero of multiplicity m, then x minus r to the m power will be a factor of f, right? So if the multiplicity is 2, you'll have x minus r squared, and so on. All right, these next two take us back to when we were talking a bit more about our quadratic formula. If we have an irrational number, like a plus b square root c, as one of our zeros or one of our solutions, then the conjugate, a minus b square root c, is also a zero of f. Okay? So what that means is if you think about where this came from, this probably came from a quadratic formula, right? This is just the positive solution and the negative solution written separately. What that means is we get two factors. They're going to look a little weird, but there's two factors that we can identify for our polynomial. We'd have x minus this one. And when I subtract it, notice I'm going to distribute the minus sign. So it'd be minus a minus b square root c. And then this one, x minus a minus is plus b square root c. Those are both factors of f. Typically, those aren't so helpful because first of all, they're a pain in the neck to try to divide by, but also usually we don't get those first, right? We usually get the rational ones first, and these ones pop out of the process, but technically they are factors. All right, and then the same thing can happen with the imaginary zeros. If I have an imaginary number like a plus bi, if that's one of my zeros, then its conjugate, a minus bi, is also a zero. And again, that really just comes from the plus or minus in the quadratic formula. Okay. That means that x minus a minus bi is one of my zeros, and x minus a plus bi would be is one of my factors of f. So what we're going to be doing in these last couple of examples is kind of turning the tables. So far, I've been giving you the original polynomial and asking you to find the zeros. This time, I'm going to be giving you the zeros and asking you to go back and tell me what the original polynomial must have been. So we're going to work on giving all of our answers as a polynomial in expanded form and descending order. And in the first case, our clues to what this polynomial is 3 is a zero of multiplicity 2, and the square root of 2 is a zero of multiplicity 1. So I'm going to start by just making a list of the zeros. 3 is one of the zeros. Because it says multiplicity 2, I'm actually going to list it twice. That'll help me remember what to do when I start writing my factored form. The square root of 2 is also a zero. And if you think about it, that's kind of like saying 0 plus the square root of 2. So if 0 plus the square root of 2 is one of my zeros, then 0 minus the square root of 2 is another one. So even though they didn't give it to me, I know the conjugate has to be in the list as well. The simplified form, of course, is just square root of 2 and negative square root of 2. So I'm listing all the zeros they gave me, including multiplicity, and I'm also including any conjugates that are relevant. All right, I'm ready to start constructing my polynomial. I'm going to call it f of x, but you can call it anything you want. I know if 3 is a 0, then x minus 3 is a factor. And the 0 had multiplicity 2, so I actually get the factor twice. And then I would have x minus the square root of 2. And then I would have x plus the square root of 2. Okay. Those are all the factors that I know must be in my polynomial. Now it says lowest possible degree, so I don't want to add any more factors just for fun, because first of all, it wouldn't be fun, but secondly, it would increase the degree if I added additional factors, and I don't want to do that. I want to keep my degree as low as possible. All right, so let's start multiplying out this polynomial. By the way, before I even start, can you tell me what the degree is going to be? I have x to the first multiplied by x to the first 4 times, right? There's 4 x's multiplied together here, so it's going to be x to the 4th eventually. This is going to be a 4th degree polynomial. All right, I'm going to start just by multiplying pairs. This first pair would be x squared. And notice that my outers and inners are both negative 3x. So negative 3x and negative 3x would be negative 6x plus 9. And then the second pair starts with x squared again. And once again, I'll ask you to notice what happens with the outers and the inners. I get a positive x square root 2 and a negative x square root 2. So that part just becomes 0. And then minus the square root of 4, which is just 2. Okay. By the way, that's going to happen every time with conjugates, right? Because one's plus and one's minus. Those middle terms, the outers and the inners, will add up to 0 every time with the conjugates. All right. I'm going to start by taking my x squared here and multiplying it all the way through here. So x to the 4th minus 6x cubed plus 9x squared. And then I'm going to distribute this negative 2. Negative 2x squared plus 12x minus 18. There's not a whole lot I can combine. I guess just the x squared terms. Becomes a plus 7x squared. So there we go. That 4th degree polynomial will have the zeros that were specified. All right, we're going to try that a couple more times. In B, I want a polynomial of lowest possible degree that has zeros 6i, positive 1, and negative 1, all of multiplicity 1. So again, I'm going to start by just making a quick list of my zeros. 6i is just like 0 plus 6i. So again, if that imaginary number is a 0, then its conjugate, 0 minus 6i, would also have to be included. So in other words, I have 6i and negative 6i. I also have positive 1 and negative 1. No conjugates because those are just whole numbers. So my polynomial, I'm going to call it g of x this time, has factors x minus 6i, x plus 6i, x minus 1, and x plus 1. Again, I'm predicting a fourth degree polynomial, right? There's x multiplied by itself 4 times. And I'm going to start by multiplying pairs. So I've got x squared. These are conjugates, so I'm expecting the outers and inners to add up to 0. And in fact, they do, right? Positive 6ix and negative 6ix. And then for the lasts, I would have negative 36 I squared. We'll have to talk about that in just a moment. All right, the second pair, x squared. And actually, the outers and the inners here add up to 0 again, right? 1x and negative 1x. And then I have a minus 1. All right, I can't remember if we've talked, well, it's been a little bit maybe since we've talked, or we haven't talked too much about that I squared. So let's just make a quick little side note about that. I, remember, is the square root of negative 1. Right? That's how we defined it in the first place. So I squared is the square root of negative 1 squared. Now squaring and the square root basically just cancel each other out, right? They're what we call inverses. So I squared is actually negative 1. So I'm going to replace this I squared right here with a marker that actually works with negative 1. So in fact, my first factor here is actually x squared plus 36 multiplied by that x squared minus 1. All right, now I can do this. X to the 4th minus 1x squared plus 36x squared minus 36, or x to the 4th plus 35x squared minus 36. Keep that one in mind. You may have to use that in these processes. Anytime you have an I squared, that's equal to and should be replaced with negative 1. All right, we've got one more example here. Polynomial of lowest possible degree. 0 is a 0 of multiplicity 3. And then we also have 4 plus I as a 0 of multiplicity 1. So making my little zeros list. 0 has multiplicity 3. So I'm literally going to include it 3 times. 4 plus I is a 0. And that means the conjugate. 4 minus I also has to be a 0. All right, that should be all of them that I need. So, let's see, we'll call this one h of x. I'd have x minus 0, x minus 0, x minus 0. X minus 4 minus I, and x minus 4 plus I. All right, this is really just x times x times x, so I can write it as x cubed. And by the way, I'm fine with you going straight from here to there if you're comfortable with that. I just wanted to be sure everybody saw where I was getting that from. All right, I need to multiply these two together, which is going to take a little bit of work, but we'll get there. I'm going to start by distributing this x. So I'd have x squared minus 4x plus ix. Next, I'm going to distribute this negative 4. So negative 4x plus 16 minus 4i. And then finally, I'm going to distribute the negative I. So negative ix, positive 4i, and negative I squared. All right, before I do anything else, I believe some of these terms add up to 0, so let's get rid of those right away. I have a positive ix and a negative ix. And I also have a negative 4i and a positive 4i. So that simplifies things quite a bit. So let's see, I've got x squared. I've got a negative 8x. Got my plus 16. And then I've got that minus I squared. That's minus. And remember that that I squared can be replaced and must be replaced with a negative 1. So that's really x squared minus 8x plus 17 in my parentheses. And to finish now, all I have to do is distribute my x cubed. So x to the 5th minus 8x to the 4th plus 17x to the 3rd. Okay. So that's how you can use clues from multiplicity and conjugates to build a polynomial if you're given the zeros. All right, that brings us to the end of section 4.4.